Okay, get ready for this. What if there was a single mathematical sentence that could describe not just the entire universe, but your mind too? I mean, a theory so ambitious it claims to finally connect physics and consciousness. Today, we are diving deep into something called the geometric unified theory, a framework that claims to do exactly that.
I mean, listen to that quote. That is the core claim right there. This isn't just another model of the brain. It's being presented as a potential theory of everything, one where consciousness isn't some weird afterthought, it's baked right into the fundamental equation of reality.
So, what is this thing, really? Well, at its heart, it's a super radical attempt to solve that ancient mind body problem, But not with philosophy, with the cold, hard language of mathematics and physics.
Now, the central idea is a real mind bender. It's proposing that mind and matter are basically two sides of the same coin. Consciousness isn't something that just magically pops out of a complex brain. It's literally woven into the geometric fabric of the universe, just as fundamental as space and time. Okay, I know what you're thinking. This sounds incredibly abstract, right? How in the world do you get from some universe-spanning equation to, the feeling of being confused or that little spark of a new idea? Well, let's dig into the toolkit it uses to actually map out our inner world. First up, I want you to imagine all of your thoughts, every memory, every idea, all existing on this vast, intricate landscape. The theory gives this a name, the cognitive manifold. Every single thought you could possibly have is a point somewhere on this map. It's the geometric stage where all your thinking plays out. Now, on this mental map of yours, some parts are smooth and super easy to get around, but other areas are all bumpy, tangled up, and hard to navigate. The theory calls this curvature. High curvature is basically that feeling of cognitive confusion. When you're stuck on a problem and the path forward is just not clear at all. Low curvature, well, that's the good stuff. That's clarity, that's understanding. So how do you travel from one of those bumpy, high curvature regions of confusion to a smooth, low curvature area of clarity? You follow something called a geodesic. This is literally the most efficient path across your mental map. You can think of it as the mathematical formula for an aha moment. It's the optimal highway to learning something new. This seesaw. We have all felt this, right? The theory calls it the cognitive uncertainty principle. It's kind of like in quantum physics, where you can't perfectly know a particle's position and momentum at the same time. This theory says you can't max out your deep analytical focus and your broad creative flow simultaneously. If you push down hard on one side, say intense focus for a spreadsheet, the other side, creative flow, inevitably goes up. It's a fundamental trade-off, but now it's described with math. All right, let's just pause for a second. I get it. A theory of everything that maps consciousness using geometry? It sounds amazing for sure, but it also sounds a little bit like science fiction. So we have to ask the most important question, the elephant in the room. What happens if this huge, universe-spanning idea is ultimately proven wrong? Does the whole thing just poof, fall apart? And this right here is the brilliant twist at the heart of this whole thing. It turns out it might not even matter. The path to building this grand theory is littered with incredibly valuable tools, the ideas, the metrics, the gears of real innovation. So even if the final destination turns out to be a mirage, the journey to get there produces a goldmine of practical inventions. See, this isn't just some philosophical game. The math actually spits out concrete, measurable things that could power a whole new generation of tech. Let's take a look at a couple of them. Think about this. We track our steps, we track our heart rate, our sleep, but what if we could track our cognitive health just as easily? So the theory proposes something called a cognometer. The idea is that a simple wearable, maybe even an app on your phone, could monitor your brain's fundamental cognitive rhythms. This could give us a real-time biomarker for mental health, maybe flagging early signs of depression or ADHD way before they become critical. For the $100 billion plus mental health industry, this would be an absolute game changer. Or what about education? We all know we learn differently, so why are we still stuck with so many one-size-fits-all methods? Okay, remember those geodesic or optimal learning paths we talked about? By modeling those, we could build educational software that literally adapts to your brain in real time. If you're getting confused, it simplifies things. If you're in the zone, it pushes you with a new challenge. In simulations, this approach is already showing an 82% efficiency gain.
This could completely reshape the massive edtech and corporate training markets. So we have these amazing potential applications, but here's where it gets truly exciting. See, unlike a lot of grand theories, this one isn't just speculation. It boils its entire massive claim down to a single testable prediction. The entire framework, all of it, the cognitive manifolds, the geodesics, the whole unification of mind and matter, it all funnels down to a single prediction. It all comes down to finding one very specific number hidden in the noise of our own brain activity.
And bears the number 0.0159 hertz. The theory predicts that our brains have this fundamental cognitive rhythm, a really slow oscillation that cycles about once every 63 seconds. If scientists can find this frequency, the theory stands on solid ground. If they can't, well, the theory falls. It is really that simple. And this isn't some pie-in-the-sky experiment either. The protocol is surprisingly straightforward. Scientists can use tech we already have, like EEG or even just tracking pupil dilation, to measure signals for cognitive effort and flow. Then they just calculate the ratio and look for that specific frequency spike. It's a clear, falsifiable scientific claim you can actually go out and test.
So where does that leave us? What does all this mean? Well, whether that 0.0159 hertz peak is ever found or not, the approach itself, that's what's truly revolutionary here.
This whole framework gives us a brand new language to talk about the mind. It creates practical, testable tools that you can slot directly into huge booming industries like AI and education. And, a lot like string theory in physics, even if it's not the final answer, its incredible ambition pushes science forward. It creates powerful new tools for everyone else to build with.
Look, this theory is a massively bold attempt to write down the actual source code of the mind. And whether it's ultimately right or wrong, it leaves us with one heck of a question. What kind of future could we build if we finally had it?